Now, it's also an exciting time out at Mars. The Perseverance rover has been doing some really great work. Has gotten down to doing the science. If it, of course, landed on Mars, right there where the word Perseverance is, well, where the dot is, at an interesting location. You can see here, it landed in a delta sort of an area. We think it was an old, well, a crater that was filled in with a lake. Water flowed in from one side, flowed out the other side. So there was great hope there's sedimentary rocks here that might show signs of life left over. It landed at that Octavia E. Butler landing site. And please Google Octavia E. Butler and go have some fun. Some great reading is in store for you if you do. Well, the rover right now has moved on over to this location here. And it's been looking at things, whereas the helicopter is also over on that side, and I'll tell you in a little bit how Ingenuity got there. And you can see the plan is to drive over a little bit further and then to return back towards the landing site and head towards Three Forks eventually. So that's sort of the planned route we're going to take. Again, beautiful views from there. These sorts of rocks we haven't really seen quite like these. They're kind of gray in color. They're covered by that, you know, pinkish dust that's everywhere on Mars. But you see these rocks that look a little bit more like river rocks you might see up in the Sierras in some of the rivers. They're tilted kind of similar directions too when you look at them. I don't know if that has to do with flow, or I doubt it's wind erosion, but maybe. But then the ones that are interesting are those flat rocks down in front. They're different than most of those other rocks you're seeing there. Those we're calling paving stones because they seem to literally pave sort of the flat area underneath all these other rocks that are laying around. So we wanted to know, what are they? And this is a close-up view of it here. You take a look at it, but it's covered by that pink dust. You have to clean that off and use the abrasion tool, which brings us to our next segment here. Is it Mars or is it Earth? We have two images here. One of them is Mars, one of them is Earth. And can you tell which is which? All right, get your votes in now. $1 million on the line. Okay, not really. There's no money on the line at all. Well, we move forward here. We take a look. The abrasion tool indeed was used. Here it is. When you look at the sort of rock surface itself, it's very, you know, chunky and whatever, but you clean it off and it's quite smooth down in there. Going forward, we zoom and enhance, and indeed, that's the one it is. And the left was a granite countertop, and on the right-hand side was a plain old Mars rock that they used the abrasion tool on. Now, what is that rock made of? We don't know. It looks similar to a granite. It kind of doesn't look very sedimentary to me. I'm not a geologist, though, so we're going to wait and see what Watson and Sherlock have to say about it. No, I am reading some Conan Doyle books right now, and I'm reading some Sherlock Holmes, but not the inspector. It's actually the instrument. And they're going to get down there and see whether it's worthwhile to take a sample. And this is the sampling mechanism they hope to use on this site, on this rock. They're going to get a core sample. Well, they're thinking about it, and that core sample is kind of similar to a size of chalk. If any of you remember what chalk is like. Hopefully kids are still doing chalk out on the street, although the ones I've seen on the street are really big and fat, so it's the narrow, thin chalks. Anyway, they've already gone in. This is kind of the machinery that's going to be used for the sample taking and everything that's going on, just to show you that it's all really there. It looks very science labby and serious. One thing they have to do, though, is sample the atmosphere. If you don't know what's in the air, and then you get a sample of rock and the air contaminates the rock, you might think something's in the rock that actually was just in the air. So they've opened up what they're calling a witness tube, and that witness tube witnesses the air that's available. So they open it up, sample the air, they clean it out, they do all their stuff they need to do, seal it back up. And then that is there to tell the scientists what was in the air when we got this sample. Now, they have gone ahead and made a little bit of a drill there. You can see the tailings. So they're preparing to take a sample, it looks like. They are going to use Watson and Sherlock, a couple of instruments. They'll use the other instruments. You don't have to get the sample right away, and they'll determine, is this worthwhile? They're hoping to sort of get a baseline. What are all these paving stones like? Because their material might be found all over the place. So they're approaching this scientifically. We don't expect to see signs of life in this sample, however. This is definitely the initial work to do it correctly, do it right, so we really understand what's going on. Now, the samples we're talking about taking, they're not even going to get back here till the early 2030s. It's highly unlikely that in the 2026 sample return mission, it's not funded, we don't know how it's getting there, so they told us probably early 2030. Now, what Chris is going to show you and talk about. Maybe there's some other folks here on Earth that might get to Mars. We'll see about that. There is another target off in the distance. This is the SuperCam RMI images of it, and you can see sort of the layered material here. This stuff might be interesting. That might be more sedimentary. When you have layers like that, you think that's sort of like a lake bed that's been laid down over time as the sediment falls down. Well, dead little critters fall down in there, get cemented in. Maybe there's some signs of life in there, little evidence of microbes, but we'll have to see. That's off in the future. Another interesting thing Perseverance has been doing some automatic driving, automated driving. That's right. It doesn't have to be steered quite as slowly like Curiosity. Now, Curiosity wasn't steered live. They would take images, they plan it out, and they make a very small move, and it had some very finite automated capabilities. Perseverance is like upgraded. It knows where it goes. It takes some very cool images, processing as it goes, and they can kind of set it free. Now, you notice the uploaded drive programs, driving it the old way was in the blue rectangle. The new way that they just tested is in that green one, and you can see how much faster they're able to go. It is a lot faster, a lot more economical, and as long as Percy doesn't decide to go drive around in the dunes and have some fun on her own, we'll be okay. Now, they doubt it will do that. They've really programmed it to avoid things that will get stuck in. They don't want to get stuck in the dunes. By the way, the top speed now has been up to about 152 meters per hour. That's 4.2 centimeters per second. So, you know, watch out. It's actually fairly quick for a rover on a different planet. That's pretty great. We don't need to be going much faster than that. It is time for our update on Ingenuity, the helicopter that was brought along with Perseverance. It had its first 8 flights in green. The 9th flight path was that one you see there. That's extra dangerous because you're flying over all those dunes. The dunes go up and down, so imaging the terrain becomes difficult. Knowing where you're going is difficult. It sort of squishes the image as you look at one slope because they can't pan the camera around. It's just staring down. They weren't really sure Ingenuity would know quite how high it was, where it was going. They did their best to program it, and everything went great. It took off. Here's some stills from the flight. You can see the shadow down below of the helicopter. It's staring straight down, getting higher and higher into the air. We're talking, 30, 40 feet in the air at this point. We're not messing around. This helicopter is actually getting high into the air. It is flying longer distances than it's flown before. This one had a horizontal distance of 625 meters. So that's, 6 soccer fields long. I mean, these distances are getting really pretty impressive that this little helicopter is flying, and you can see the scouting is pretty neat. You're looking down there at rocks. We're seeing sand dunes. You can evaluate terrain, and it gives you an unusual perspective that Perseverance can't get sitting on the ground looking forward. So this little test vehicle, remember, this was just a prototype to see, will it work at all, is looking like it's going to pay off and be exceptionally useful for future exploration as long as it can keep up with the rover. Speaking of which, it had a 10th flight as well as the 9th flight that was very complicated. There were 10 waypoints along the way that the computer had to see, analyze, recognize, and then continue on its way. It successfully did all of that as well. So a 10th flight in the books that was great. You can see some information about the flights here and the horizontal distances that have been going up, 2,051 feet. That's not quite half a mile, but it's a third of a mile. It's more than a third of a mile on that longest flight. So pretty crazy flights from the helicopter. It made an 11th flight too, but very short. Just did a little hop, relocated to a new sort of airport for it, so to speak. Lastly, from Mars, I know it's been a long Mars report, but we didn't talk Mars last month. The InSight lander has still been making measurements. Remember, this is the one that has the seismograph on Mars. It's capturing those pictures of clouds going by from the surface of Mars, a lot of fun, but it's also making measurements of Marsquakes. You can see here, the ground shakes, it picks it up just like our seismograph at Griffith Observatory, and you can use Marsquakes to measure the internal structure of a planet. The earthquake happens, it bounces off the different layers inside, comes on up and is received by Ingenuity. Depending on how those reflections are measured, how they arrive, it tells you about the structure. And there were 3 basic ideas we had, 3 possible inner structures for Mars: sulfur-rich, molten iron nickel core, and no plate tectonics. In other words, it's pretty locked up on the top. Or the second choice, sulfur core, not a lot of sulfur, inner and outer iron nickel core, and it's just not sufficient to drive those plate tectonics. So again, there is an outer core that's moving, but it's not making the plate tectonics. And then lastly, two layered core like Earth's, and indeed there's some plate tectonics going on. Now we don't see signs of that on the surface. We see volcanoes, we don't see a lot of motion. So we didn't think the third one necessarily, but maybe. Well, Insight rather has shown that it's most likely the top one, that the core is probably sulfur rich, that it's molten iron nickel, and that there are no plate tectonics, just like we see. So this is our probable model for Mars at this time. You can see the radius, 3390 kilometers. The mantle is quite thick. The crust, not all that thick, 24 to 72 kilometers, fairly thin, but it's not convecting, it's not moving, so it's locked in place. This leads to things like huge volcanoes like Olympus Mons on Mars. So very, very interesting. There still might have been life in ancient times on Mars, but it's a lot harder to do if you don't have something like plate tectonics to drive and recycle the atmosphere. And also, it might give you more volcanoes that might help you produce more atmosphere at the plate boundaries where they interact. So different story, we need to learn how Mars evolved.